Algebra I, 6.9c, word problems using variation, y equals kx or y equals k divided by x. If you haven't seen the previous videos for Chapter 6, we're almost near the end. There's 18 videos before this one. You might become lost or confused, and those video links are in this video's description, so you can watch them real quick. Equations of direct and inverse variation can serve as mathematical models for many situations. We can solve problems related to them by using problem-solving guidelines. We need to understand what the problem is asking, come up with a plan, and answer and check our answer. So remember, direct variation is a functional relationship that's represented by an equation y equals kx, where k is a non-zero constant, like the money you earn is going to equal how much you're being paid per hour times the hours you work. Inverse variation is a functional relationship that's represented by the equation y equals k divided by x, where k is a non-zero constant. So that might be the time it takes you to get home is going to equal the speed you go divided by the distance. All right? So take a look at this. The volume of water produced from melting snow varies directly with the volume of snow. Meteorologists found that 150 cubic centimeters of snow in one watershed melted to 16.8 cubic meters of water. So here's a watershed. Let me get a closer look for you here. See this picture? We've got the land, and it looks like it's all going downhill, so the rainwater can just slowly go downhill towards the lakes or the ponds or the rivers. It's an area or ridge of land that separates waters flowing to different rivers, basins, and seas. See? That's a watershed. Now suppose 200 cubic centimeters of snow melts there. Predict the resulting volume of water. So it was 150 melted to 16.8. Now we've got 200. What is it going to melt to? So we think 200 cubic centimeters of snow will melt into how much water? We know 150 cubic centimeters melted into 16.8 cubic centimeters of water. So the volume of snow varies directly with the volume of water. So let's look for that constant of variation and then the equation of variation. We're going to let W equal the water volume and S equal the snow volume. That's going to give us W equals K times S. We can substitute our values in that we know, the 150 and the 16.8, into our equation here, and we have to divide both sides by 150 to isolate that K to solve for the K, and we get 16.8 divided by 150. That's going to equal 0.112, 112 thousandths. That's going to be our K. So the equation of variation is W equals 0.112 times the S, the snow. So now we can use this equation, substituting 200 for the S. W equals 0.112 times 200. We get 22.4. So we know that the water will be 22.4 cubic centimeters if the snow is 200. And this is a reasonable answer because 22.4 is about 1/9 of the snow, as 16.8 is about 1/9 of 150. See? So it's reasonable. All right, let's take a look at this one. We've got some bleachers here for a football or a soccer game, and the time T required to do a job varies inversely with the number of people, P, who work on the job. If it takes 4 hours for 12 people to erect some football bleachers, predict how long it'll take for 3 people to do the same job. So we think, how long will it take people to build the bleachers? That's 9 less people. We've got 3, we had 12, so it should take longer, right? We've got less people. So if it takes 4 hours for 12 people, time will vary inversely by the amount of the people. We look for the constant of variation and then find the equation of variation. So the time is going to equal K divided by P. All right? We can plug in the information we have. We can substitute it in, and we've got 4 hours and 12 people. We do 4 equals K divided by 12. We can multiply both sides by the 12 to isolate and solve for the K. And we get 48 for K. The equation of variation is t equals 48 divided by p. So now we have 3 people. We can substitute the 3 for p and get t equals 48 divided by 3. 48 divided by 3 is 16. So the time is going to be 16 hours for 3 people to build the bleachers. The time is reasonable because it would take 3 people 4 times longer than 12 people. So we know we've got it right. Our answer is reasonable, okay? Looks to me like they should do it with the 12 people if they can, because then it wouldn't take so long, right? All right, our next video is 6.10, and we're going to do word problems and problem-solving strategies of making a table and looking for a pattern. I'm going to add this video to the Algebra II playlist so you can use it to study and review. And those previous videos from Algebra I that talked about direct and inverse variation, 12.6a and b, are going to be in this video's description as links, and all the previous current Chapter 6 videos that'll be helpful to you, okay? One click away. I'm handing you all this information to help you. It's up to you to use the information I'm giving you, all right? So I hope you're doing well. I hope you're having a really great day. Keep trying. You're going to be able to do this. I believe in you. Bye.